All right. One thing, last night around midnight, I uploaded a link for you guys to use. It's a survey via Google Forms. And when you go to college, at the end, what? I didn't hear you. What? Did you
But I
get it?
looked at it, but I didn't do it. It looked hard.
I'm already done with mine. Me and my mom both did that together.
Please do it. Why aren't you going to do it?
I'll do it. I'm just like, nah. I looked at it last night and I was like, nope, that's gonna have to wait till another day.
Well, here's the thing. When you go to college, what happens is, well, if you go to college, which Maddie, I don't know if you will or not, but that's another story.
I will go to college.
All right. When you go to college, at the end of the semester, you have a course critique where you basically grade the teacher, and they ask you, okay, well, what did you like or dislike about the course? What did you like or dislike about the instructor? Is there any way he can improve or she can improve? And then normally the instructor is supposed to take that criticism and improve going forward. So I wanted to give you guys a taste of that.
I don't think you care, though.
One of those things. Now, if you do it, if you do it, I will give you a few bonus points. Because remember, I said from day one of class that you're not the only one coming to class. I'm also a person coming to class, and you're learning geometry or trying to learn geometry, and I'm trying to become a better teacher. So if you tell me what my
Okay, I'm down for some bonus points. So that will make me do it.
Yeah. If you do it, I'll throw some bonus points your way. All right? Honestly.
Good.
So there's a section for you, and then there's a section for your parents as well. Okay. So it helps me out substantially because it may or may not affect you because I don't know if I'm going to have you as a student next year, but it will definitely help your colleagues.
I'm on a Zoom call.
You know? And be as brutal as you'd like. You're not going to offend me any, and I'm not going to take it out on you or anything because, I mean, I like growing as a person. So, all right. Okay, so.
I mean, I'm pretty sure you're just not going to care.
No, I do. I read all of them. I've read everyone that's come to me so far. And there are a couple of suggestions that I will definitely be considering, you know, adopting next year. The main thing I highlighted was the speed is not really my doing because I have to cover a certain amount of information in a certain amount of time. So some people like, go slower. I can't go slower because if I go slower, I'll never be able to catch up. All right, let's get started. Okay, so let me share the screen. Hold on. Okay, so there is a problem that you have where we're talking about area of a parallelogram and area of a triangle. So just to remind you the formulas, the area of a triangle is 1/2 base times height. And the area of a parallelogram is base times height. Now, that makes sense because a triangle is basically half a parallelogram. Now, the thing to remember, the thing to remember is that the height is actually the altitude. Altitude is the line perpendicular. So you just can't pick any two sides. You have to pick the side that is perpendicular, and the base has to be the side that height is perpendicular to. So the question occurs, what happens in a situation like this, where you are given a parallelogram and you're asked to find the area? So when you're on a coordinate plane, there's little tricks that you can do, okay? And it's called the box method. So what you do is you take the parallelogram and you square it off. Okay, like that. You can square it off.
What is that?
What, the music? Yeah, it's my annoying cuckoo clock. So Apologize for that. So you want to square it off, okay? Now, remember the area of a triangle is 1/2 base times height. So let's take, for example, this triangle right here. Okay. This triangle has the base 1, 2, 3 and the height 1, 2, 3, 4. So the area is 3 times 4, which is 12, divided by 2, which is 6. Here, the area is 1, 2, 3, 4, 5, 6 times 2, which is 12. Half of that is 6 again. This guy right here is 1, 2 times 1, 2, 3, 4, 5, 6. So 6 again. And this guy will be 6 as well. Okay. Now, you know the area of each one of these small little triangles. So the area of this big rectangle is base times height. So the base is 1, 2, 3, 4, 5, 6, 7, 8, 9. And the height is 1, 2, 3, 4, 5, 6. So the height is 6. So the area of this red rectangle is 54. Now, to calculate the area of the parallelogram, let me ask you a question. Say, for example, I give you a piece of paper and I say the area, the space in between is 100. And I cut out a circle whose area is 30, okay? What is the area of the remaining paper with a circle cut out? How would you calculate that?
70?
Hmm?
Is it 70?
How'd you get it?
100 minus 30?
Right, so if it's 100 for the whole thing and 30 is the amount that you removed, then it's 100 minus 30. So in the same logic, you can do this, okay? The area of the full thing is 54. The area of each small triangle is 6. So the area of the parallelogram, which is between those triangles, is 54 minus 24, because the sum of the small triangles is 6 times 4, which is 24. So the area of the parallelogram is 30. Okay. Does everyone see what I did? Parallelogram is a piece that I'm cutting out. Okay, is the piece that is left over. The little 6s, the little triangles are the ones that I'm cutting out. So if the full thing is 54, and I cut off each triangle that is 6, and there's 4 triangles, what's left is 54 minus 24, which is 30. Does everyone understand? And this is called the box method. So if you have a parallelogram with sides that are not perpendicular, box it around into a rectangle, measure the rectangle, we'll find the area of the rectangle, and then find the area of each little triangle and subtract it from the area of the rectangle, and you'll get the area of the parallelogram. Okay. Now, what if I wanted to find the altitude of the parallelogram? How would I find the altitude of the parallelogram? So let's say, for example, this side is 7. Okay, the length of this side is, say, 7. How would I find the altitude of the parallelogram? So the side that is perpendicular to this side that is 7. How would I find that? Well, the area is equal to base times height, where the height is the altitude, and the base is what the altitude is perpendicular to. So if the area is 30 and the base is 7, I can find the altitude, the height, by dividing it. Okay. Any questions? Are we good? All right. Now, let's talk about the area of a trapezoid. Okay, the area of a trapezoid. So remember, a trapezoid is not a parallelogram, but it is a quadrilateral. Okay. And it's not a parallelogram because both sets of opposite sides are not parallel. In a trapezoid, remember from our discussion in class, only one set of opposite sides are parallel. Now, the area of a trapezoid is given by 1/2 times the altitude, or the height, times the sum of the two parallel sides, or the two bases. All right, sum of the two bases. So key point, it's the sum of the bases times the altitude, the line perpendicular, times 1/2, or half that. Now, that's trapezoid. Now remember in class when we were talking about parallelograms, we talked about a specific type of parallelogram called a rhombus. And a rhombus was a parallelogram whose sides are all the same. And the unique thing about the rhombus was that the diagonals are actually perpendicular to one another. The diagonals were perpendicular. Now, to find the area of a rhombus, okay, the area of a rhombus, it's 1/2 times diagonal 1 times diagonal 2. Okay. 1/2 the product of diagonal 1 times diagonal 2. And we didn't talk about this shape in class, but then there's another type of shape called a kite. And a kite is any quadrilateral whose diagonals are perpendicular to each other. And the area of a kite is the same as a rhombus. It's the product of the diagonals. Any questions so far? So the area of a trapezoid is 1/2 times the altitude times the sum of the bases, the sides that are parallel. The rhombus is, and the kite is 1/2 times the length of the diagonals. So let's look at the summary of area, okay? So triangle was 1/2 base times height, and height has to be perpendicular always. Base is what the height is perpendicular to. Parallelogram is just base times height. Again, height is the altitude. Trapezoid is 1/2 height times the sum of the bases. And rhombus and kite is 1/2 times the diagonals. Okay. Any questions so far? All right, let's look at some problems. So you're going to need a calculator to do this. Okay. Let's do number 11. Find the area, please. Number 11, please. You like Fruit Loops, Maddie?
I actually just figured out how to do this, so I'm just finding them off the web at the moment. I have a good one though. Wait, I've got one.
We're totally paying attention. I don't know what you mean.
Right, like I'm learning.
Let me see something here.
So now I'm listening from the beach.
My favorite's still the Joe Exotic one.
I know, I changed him because like I had to hold my head at a weird like position to put it there.
I'm in The Shining.
We're gonna do one.
Come play with us.
Oh my god. Okay, I almost did that one, Kristen.
How'd you even find them? Like,
I just looked up
Google.
backgrounds.
I'm gonna need a link. All right.
Just go on Google.
Literally type in backgrounds.
There we
Zoom.
go. Mr.
There we
D.
go.
All right.
What do you do? What do you do?
Maddie, this is the Theater Guild Zooms all over again.
Oh no, that was a problem.
Alex.
I'm in love with myself.
Oh gosh. Wait, I've got you. I got you beat. Hold on.
I would hate to put myself as a background because I'd be looking at.
Hold on.
Kristen, you look like you're
I gotta
you're
find
part
it.
of that. You're in that movie, The Shining. You look like you're in that hallway where that little. Did you ever see the movie, The Shining? Yeah, you look like you're. part of that
Yes, I
hallway.
have. It's one of my favorites.
Yeah, it looks like that. Oh,
I also watched Dr. Sleep, which is the sequel to it.
hmm.
I'm
Let's
a
see if I
big
can do
horror
another.
movie person. Maddie.
Can we just do this all day?
This is my old Smule account, that like karaoke app. Hold up.
This is fine. Everything is fine.
Okay.
Well, I've always wanted to have a video game after
Oh,
myself.
there-
Here we go. You know.
Oh jeez. Ow, my ankle pop.
Ba-dum-bum, ba-dum-bum. All right, let's do this problem. So let's set up the problem. If area equals 1/2, what's my height? What's the measurement of my height?
5.
5 times base 1 plus base 2. So remember, you have to add first, so that's 12.2. So if you plug this into your calculator, you should get 30.5. Any questions? Are we good? Kristen, are you fine? All right. Okay. Let's look at a problem like this. Okay, number 38. Nice photo. Area.
That's my kindergarten.
I couldn't find any of mine. We're good.
That's my Trinity private school photo. It's
You went to
cute.
Trinity?
My jumper is plaid and you can't see it. I did.
Maddie, you
For
remember when I
3
had
years.
long hair and bangs?
Oh my gosh, wait. Here's Okay, one more. I had bangs, and it
Okay.
wasn't good. Oh my gosh. I have to go back to where the other one was.
No one ever wants to see mine because I look like a woman and it's weird.
Bang, where?
Wow, where was that? You do look like
Fourth
that.
grade?
Really?
Fifth?
Quite precocious.
Mm-hmm.
Wow.
I know.
Hmm. Still
I have
pretty.
one more just to expose Brandon. Thanks.
Okay. While she's uploading that, let's look at this equation. So I'm asked to find the other base. So here I've been given the area of the trapezoid and I'm asked to find the base. So you use your formula, 1/2 height times base 1 plus base 2. You put in the numbers that you're given and replace this thing that you're not given with x, or the thing that you're trying to find with x. And now how to solve this? Well, what I would do is try to get rid of the 1/2 by multiplying both sides by 2. Then I would divide by 5.2. And 53 plus 5 divided by 5.2. I can't do that in my head, unfortunately. That's 10.19. So x plus 2.6 is 10. Let's say 2. Subtract 2.6 from both sides. X equals 7.6. So if you're asked to find the base, the first thing I would do is get rid of the 1/2 by multiplying both sides by 2. Then divide by the height, which is 5.2, and then subtract the base that you're given. Right? Any questions? Are we good? Is that you, Kristen?
Yeah.
I didn't see it. You need to go move to the side. Pretty nice.
Hold on, mine's about to be Kristen from 2nd grade.
I haven't aged.
Hold on, mine's about to be long hair.
No, really, you haven't. You look almost exactly the same, honestly.
Baby faced.
Mm.
Maddie Grace, if you.
I'm doing it. Hold on.
Maddie Grace.
I gotta find it. Whose
Go
class
back
are
to
you?
this.
Mine is a picture of me when I tried something different with makeup.
Oh, that's a nice photo of yours, too.
I found it.
Maddie Grace, don't you dare.
I found it.
This is why I cut my hair.
You look nice with long hair.
Bro, I gotta get that lighting.
All right. Apparently the camera does not want the Zoom does not want to put the photo of Maddie Grace up because I guess it's that horrible.
No, actually, I'm just editing it.
Oh, okay. I thought maybe Zoom said, nah, I can't do it too.
No, it's not gonna be me. It's Kristen.
Oh, okay.
Why does it have to be me?
All right. So the last thing I want to talk about before I let y'all go today is, that's nice. Chubby cheeks. I want you
Wait,
guys to
I had to do it to
remember
myself.
what we talked
I used to be
about
fat.
when we talked about polygons. So I don't know if you remember this, probably not, knowing most of my students. When it came to the interior angle sum, the exterior angle, and the interior angle of one angle of a regular polygon. So remember, in order for a polygon to be regular, it has to be convex and all the sides must be the same. So remember what it means for a polygon to be convex. If you extend out all the sides, none of the sides go on the inside. So the first thing, in order for a polygon to be convex, for it to be regular, it must be convex. So number 71 will be an example of a convex polygon. And it's actually a regular polygon because all the sides are the same. Okay. Now, let's say, for example, I had something like this. A chevron, if you will, or a Decepticon symbol, if you know what that is. This can never be a regular polygon, even if the sides are all the same, because it's not convex. So if you look at it, if you extend out all the sides, these two sides right here go actually on the inside of the polygon. So this one and this one go on the inside. So because it goes on the inside, it is not a convex polygon. It's a concave polygon. Okay, remember, you go in a cave. Okay. So if it's a concave polygons can't be regular. Now, we talked about the sum of the interior angles of a polygon. And the way we created it is say, okay, if you have a polygon like this, it's not a regular polygon. Let's say it's just a normal polygon of some kind. It's not regular or anything. How do we find what all the inside angles will add up and give you? And the way we do that, remember, we've had this discussion in class. The first thing we want to know is how many triangles are in this polygon. So if I start at this vertex and I connect a line to all the other vertices, it breaks up the polygon into 1, 2, 3 triangles. Okay. Well, this polygon has five sides. Okay. So there's a relationship between the sides of a polygon and the number of angles that it has. And let's do another one and I'll show you the relationship. So let's take a hexagon. And I do the same thing. I start at a vertex, it doesn't matter which vertex, and I connect a line to every other vertex. And by doing that, it breaks the polygon into triangles. And how many triangles? 1, 2, 3, 4. So a polygon, but this thing has 6 sides. Okay. So look for a pattern. In the previous example, you had 5 sides and it had 3 triangles. And in the next example, you have 6 sides and you have 4 triangles. So if I had a polygon with 10 sides, how many triangles would I have?
8.
Okay, how'd you get that?
Just going up by 2s.
Right. So if the number of sides and the number of vertices in a triangle is given by n, the number of triangles is n minus 2. Okay. And this is going to give me a clue as to how much, what the sum of all the inside angles will be. Because in a triangle, what are the sum of the angles in a triangle? What does it equal? Do y'all remember if all the angles of a triangle add up and give me what? How many degrees?
180.
180. Okay. Well, if each triangle adds up to 180 degrees, and in this case I have 3 triangles, so the sum of all the angles would be 3 times 180, which is 540. Okay. Same story. Here in this diagram, I have 4 triangles. Each one is 180. So the sum of all the inside angles will be 4 times 180, which is 720. So that's the pattern, okay? And hopefully you see it. And given a polygon with n sides, the number of triangles is n minus 2. And the sum of the angles is n minus 2 times 180. Now this is for any polygon, okay, with sides n. And we call this the interior angle sum. Now, this does not say that all of the angles will be the same measurement, because some angles will be larger than others in a irregular polygon. But if you add up all the degrees, it will be n minus 2 times 180, where n is the number of sides. Now, if I'm dealing with a regular polygon, okay, then all of the angles have the same measurement. Well, let's look at this situation right here. If the sum of all the angles in this polygon is 540, and each angle is the same measurement, how many angles do I have in this shape? Mr. Caleb, how many angles do I have in this shape?
How many angles do you have in which one?
In this top shape, in the blue shape.
How many angles? I mean,
How many
I know
vertices?
1, 2, 3. I see 1, 2, 3, 4, 5, 6, 9.
How many of these angles right here, these vertices? How many?
Oh, 1,
1, 2,
5.
3, 4, 5. So remember, in a polygon, the number of sides is equal to the number of angles. Okay, so if the sum of all those inside angles is 540 and each angle is the same measurement, and there's 5 of those angles, how do I find the measurement of each one in a regular polygon? It's the sum of the angles divided by the total number of angles, which gives me 108. So in a regular polygon, and in a regular polygon only, okay, in a regular polygon only, if you do the angle sum and divide it by the number of angles, which is also equal to the number of sides, that gives you the measurement of one interior angle. So the formula for an interior angle is n minus 2 times 180, which is the sum of the angles divided by the total number of angles, which is n. Right. Do y'all remember going over this?
Yep.
Okay. And this formula only works for a regular polygon. Okay. Any questions? All right, now, this is the formulas for the inside of the angles. For the outside, okay, for the outside of a polygon, notice something. This is, all of the sides are interconnected. So they're kind of circular. So look at it this way. This is a polygon with with 5 sides. With 6 sides, it looks like this. With 7 sides, well, I'm not going to draw 7, but let me draw 8. That's 8 sides if it didn't look so weird. So the more sides I get, right, what shape does this get, does the polygon approach? What does it start looking like more and more if I increase the number of sides? So this is 5 sides. This is 6 sides. This is 8 sides. So as I get more, if I add more and more sides, like if I have a polygon with 10 sides, or a polygon with 100 sides, or a polygon with 1,000 sides, what shape does it start resembling? Can anyone tell me?
A circle.
A circle. Good. Now, what is the degree measure of a circle? We talked about this. Going around
360.
360. Remember I told you about that coffee shop incident that I had about that girl? She said that her boyfriend or somebody did a 360 even though he did a 180. So around a full circle is 360. So if a polygon, if you keep adding sides, approaches a circle, so that tells you what the sum of the outside angles will be. So these are your outside angles right here. Okay. So since a circle is 360 degrees, the sum of the outside angles of a circle is also 360 degrees. Okay. So let's review. This is the sum of the inside angles of any polygon. This is the sum, this is the calculation of one angle in a polygon, a regular polygon, inside angle. And the sum of the outside angles in a polygon is 360 degrees, kind of like a circle, because it is circular in nature, especially when you increase the number of sides. Now, that's in any polygon. But in a regular polygon, all of the outside angles are the same as well, okay? All the outside angles are the same. So in a regular polygon, all the exterior angles are the same as well. So in order to find the measurement of the one of those exterior angles, well, notice in this shape right here, how many exterior angles do I have? 1, 2, 3, 4, 5. So I have 5 exterior angles, okay? So in a polygon, the number of outside angles is equal to the number of inside angles, which is also equal to the number of sides. So if I'm dealing with an exterior angle, okay, if all of the exterior angles add up to give me 360, okay, all the exterior angles add up to give me 360. And there's n exterior angles, the number of sides. In a regular polygon, the measurement of one of those exterior angles is 360 divided by n. So the thing you have to differentiate in your brain is when you're dealing with any polygon versus when you're dealing with an regular polygon. When you're dealing with any polygon, the sum of the sum of the insides is given by this formula, and the outside equals 360. Okay, so this is the formula for the inside, and the outside is 360. When you're dealing with a regular polygon, the number of sides equals the number of inside and outside angles, and each one of those angles being the same. To find one of those measurements in a regular polygon, you divide it by n. And to find the exterior angle measurement, it is 360 divided by n. Okay. Now, one more relationship that you need to know. So say, for example, this is the inside angle of a polygon. Okay. This is the outside or exterior angle right here in red. Okay. What is the relationship between the outside and interior angle? What do these two angles add up and give me? Can anyone tell me? We've been talking about these angles since the beginning of school.
180.
Why is it 180?
Because it's a straight line.
Line, right? It's a supplement. They're supplementary angles. We call angles that add up to 180 supplementary. Okay, so the relationship between the interior and exterior is this: they are supplementary. Okay, so that means that if you take the interior angle, and you can find one of those in a regular, and you add it to the exterior angle, you should get 180 degrees. Any questions? Are we good? All right. Now, let's talk about the area of a regular polygon, okay? So let's go back to our friendly neighborhood pentagon. Okay. Now, if I use the center of the pentagon and connect the center to every vertex, I get these triangles. Does everyone see that? Okay. If I draw a line from the center to the side of the pentagon, okay, the line from the center of the polygon to the side, that is known as the apothem. Okay, the apothem. And the apothem is basically the altitude of these triangles, okay, the altitude. And the apothem also bisects the side of the polygon. So remember, these things, each one of these triangles that we're dealing with right here, each one of these triangles is an equilateral triangle. Not an equilateral, I mean an isosceles triangle. And remember, the altitude from the vertex angle of an isosceles triangle bisects the opposite side, okay? So the apothem comes from the center, is perpendicular to the opposite side, and it bisects the opposite side. Well, what is the area of a triangle? We talked about this. The area of a triangle is 1/2 base times height. Okay. Well, the base, remember, is the side of the polygon. And the height is the altitude So another name for the height is the apothem. Okay, so the area of this one triangle is 1/2 the side times the apothem. Well, how many triangles do I have? I have 1, 2, 3, 4, 5. I have 5 central triangles, okay? This is different than those triangles that we had in the beginning when we were calculating the sum of the interior angles. These are central triangles because their vertex angle is from the center. Okay, so there are 5 central triangles. Well, notice something. In any polygon, regular polygon, the number of sides equals the number of interior angles, which equals the number of exterior angles, which also equals the number of vertices, these points right here. And it also equals the number of central triangles. So if I know the area of one of those triangles, one of those central triangles, to find the area of the entire polygon, I just multiply by the number of sides, which is equal to the number of central triangles. So the area of any regular polygon is n over 2, the number of sides over 2, which is also equal to the number of central triangles, times the side length times the apothem. Okay. So an easy problem would be something like this. Okay. What is the area of this regular polygon? Again, remember these formulas are for regular polygon only. The only one that was not for regular was the sum of the interiors. So how do we do this? Okay. Well, we know the side is 4. Okay. And we know it's a pentagon, so it has 5 sides. And we know the apothem is 5 as well. Okay. And so it's a regular polygon, we plug it in. 5/2 times the side length, which is 4, times 5, which is the apothem. And if you plug this into your calculator and turn the crank, you get 50. Now, another way I can ask you this problem is I can give you the area of a polygon and ask you for I can give you the area, the side length, and the apothem, and ask you how many sides does this polygon have, okay? So for example, I can say the area of a polygon is 100, okay? The side length is, say, 10, and the apothem is 2. How many sides does this polygon have? Well, since it's a regular polygon, I can use this formula. So the area is 100, n, which is the number of sides, which I'm looking for, over 2, divided times the side length, which is 10, and the apothem, which is 2. So remember, S is side length, not the number of sides. What I'm looking for is n. That tells me the number of sides. So 10 times 2 is 20, times n over 2 gives me 20n divided by 2, which is 20n divided by 2 is 10n equals 100. Divide both sides by 10. And I get that the number of sides is 10. So it's a decagon. Okay. Any questions so far? Are we good? Really, Maddie, honestly, that's the best screensaver, I mean, the best background picture you could think of? He's a horrible person.
It was the first one that came up.
He's a horrible
That
person.
was the first one that came up.
Right, right.
It was. I'm so serious.
Okay.
And I didn't want to like put one up of you and your son. So
My son will be happy with that because he likes being a celebrity. Okay, here's one problem.
well,
We got to end this fast, and I'm going to do this last problem. We're going to end it before things get. I don't want to break Zoom. I don't want to be the one. I don't want to be on the NBC Nightly News. That's somebody put up the photo of a math teacher and Zoom shut down.
I'll go back to being sushi.
I'm just upside down.
I'll see that. It's pretty good.
Wait, how do you hold on? I'm concerned.
Okay, so what if I gave you something like this and I asked you for the area? I gave you the side length, which is 6, and you know the number of sides, which is 5, but you don't know the apothem. Okay? And you need the apothem in order to calculate the area. Well, remember, this is perpendicular. And if it's perpendicular, I know that if this whole thing is 6, that means each piece is 3, okay? So I want to find this apothem. Well, how do I find it? Well, look, that's a special type of triangle. And
Pythagorean theorem.
Yes, Pythagorean theorem. So 3 squared plus the apothem squared equals the hypotenuse, which is the side from the line from the center to the vertice. So 9 plus a squared equals 25. So a squared equals 16. A equals 4. So the apothem is 4. And then you plug it in. Area equals 5 divided by 2 times 6 times 4. And if you run the numbers, you get 60. So you may have to use the Pythagorean theorem if you're given a side and you're given a line segment from the center to the vertices, okay? Remember, the apothem bisects the side into 2 equal pieces or cuts it in half. Any questions?
No.
Oh,
I'm
you
almost
look like
done.
a
I'm almost
model.
done. Hold on. I'm almost done with my grand finale.
Okay. Ella, you have that model look.
So if I'm upside down and I'm holding my, I have to do it like this.
You're breaking the law again, Mr. Caleb. This time you're breaking the law of gravity.
I mean, first law broke was coming here, so.
Any questions? I'm waiting for Maddie's last photo, and then, you know, we can dismiss the class. Hopefully
Okay.
she doesn't. The last photo. Mr.
Okay.
Monitor, did it help? Did I help you answer the question that you had earlier?
Me?
Monitor.
The other Mexican?
What? Hey.
I gotta turn sideways. Hold on.
Did it help?
No,
Mr.
it's not
Monitor?
showing. Hold on. I have to fix it.
I
Okay.
have another question.
You do? What is it?
No, I don't.
Okay. But did it help?
Yeah, it helped. It helped a lot.
So I gave you one other retake on the unit test. So
Yes, sir. I saw
circles, just so be careful when you take it because this probably will be the last one that I can give.
Yes, sir. Thank you.
You're welcome. Sushi.
No.
Now I'm hungry. Thank you. Any questions?
Yeah, how do you put the camera back to normal?
I don't know. Reset it. That's what I do. I turn it off and on.
It's getting trippy.
Maddie's having way too much fun with this.
I got a little math equation for you at the end. And ignore my little typing bar.
What, the people actually working, me and Kristen. The people actually working is less than me and Kristen. Yeah, I know. Anyhow, I got another lecture for a college class later on, so I got to get going and get ready for that. If you have nobody has any questions, I will see you guys tomorrow. Have a nice day, guys.
Bye.
You too.
I'm not.
gonna start
Remember
coming
to
to
do
these.
the. Remember to do the. Press the link and do the survey. I'll give you some bonus points. And if you have any questions, let me know. I'm having a hard time uploading some of these videos because my internet is terrible ever since my house got struck with electricity. So, oh well.
I mean,
try to
it makes sense.
But so we'll see.
A million bolts in the house. It's not.
Yeah, well, maybe I'll just go up to the lake this weekend and just upload it there. So we'll see.
Yo, I'll be there next weekend.
Oh. Where do you have a house? Which Lake Martin?
I don't.
Oh.
Yeah.
I mean,
Which
I work
number?
there, so.
Well, when you guys are up there, let me know. I'll let y'all come over.
Oop, I'm done.
Oh,
All right.
Yeah. All right. Y'all have a nice day. I'll see you guys tomorrow.
Me too.
Mhm.
Bye.
Reach out to me if you need any help. Do the survey.
I won't forget about the survey.
Yes, ma'am.
Probably.
I will forget about the survey.
I'm going to blow up your phone with messages.
I'll be there to remind both of them.
Thank you, Kristen. That's fine. Thank you.